My name is Sean Orlowitz. I actually manage the Phenologics group at Phenomenex. What Phenologics is, in its simplest definition, we're the applications laboratory for Phenomenex, but we do things slightly differently. So we do generate a lot of technical literature and things to that nature, but really the majority of our work is actually working with individual clients. We try to mirror your laboratory. So we have 12 scientists currently, our own facility. It looks like a laboratory probably just like yours, a bunch of HPLCs running, some GCs, some GCMS, 3 triple quad mass specs, and a Tecan EVO. But the difference between our lab and most of our customers' lab is we are a method development laboratory. I'm a lucky uncle, and unfortunately or fortunately, I'm not a parent. And I feel sometimes like being my lucky uncle. I get my little nieces for a day. I feed them ice cream and junk. I get them very, very excited. And then at the end of the evening, when they're starting to melt down, I give them back to their parents and go home. And that's very true in our laboratory. We don't do a whole lot of production samples. We're doing method development. And so one of the things that we've been working with Tecan quite closely on is automating exactly that. We're using a liquid handler not to necessarily increase our throughput and go faster for a particular assay. We're trying to develop methods faster. We're trying to get more molecules in and out of our laboratory and optimize the chromatography faster. And so it's a little bit of a unique use for these tools, but at the same time, we've been very, very successful at it. And so we're starting to share some of that data. So today, we're just going to talk about automating SPE method development, but I'll bring up some of the other things that we've been able to do with this instrument. So this is our laboratory. This is our Tecan EVO 100. Our lead extractionist is a woman by the name of Shahana Huck. Her actual middle name is Roma. So now we have a picture of her on the little Roma arm. It's been a very versatile tool for us, but just to show you some of our maybe our setup, we've got a TVAC to use for 96 well plate extractions, orbital shaker, a couple plates, some labware, and some carriers that we use. In terms of sample preparation, maybe just to back up a little bit, we do it all. And our laboratory is aimed at mirroring yours. And so we aren't necessarily the marketing group that's going to just show everything on solid phase extraction. The question is, what's the right tool for you? If you can get away with a simple protein precipitation, we do them in our laboratory every day. Solid phase extraction, as you go up this list, you get more specific in terms of your extractions, in terms of your cleanliness, in terms of what type of specificity you can get out of extraction. But admittedly, you also go up in cost. And so I'm not necessarily suggesting that solid phase extraction is for everyone, but unfortunately with the biological matrices that we deal with, at the concentrations that we're typically dealing with, solid phase extraction becomes really the only way to get highly selective extraction procedure as well as concentration. So why do we do SPE? Number one, and in my opinion, is the cleanliness. Simple, right? We're trying to reduce background. Number two, I love this graphic just because I live in Southern California and sharks are kind of an issue. Concentration. Mass spectrometry is a concentration-specific detector. Early on in my career, I was working on a very challenging assay that's still around today, plasma metanephrin, and I called the best mass spectrometrist I knew because I was struggling with sensitivity, and I explained myself very in depth to them, and their most technical answer to me was inject more. Thanks, appreciate all your help. So concentration is a very handy step that both SPE and some of the other SLEs do. So one idea that we come up with, we were collaborating with a customer, a small contract research organization. They have typically 1.5 to 2 days to develop a method for their analytes. Pretty simple in terms of chromatography. We're talking about parent metabolite studies for drugs and exogenous materials, but at the same time, to develop an extraction in a day or two is very, very challenging. I mentioned Shahana Huck earlier. She's been with Phenomenex for 15 years. She has worked on the development of every single Phenomenex sample preparation product. And we're lucky enough to have her on our team. She is an expert extractionist. It takes her on average 11 days to develop a method. And she's great. So to do things in 2 or 3 days, sometimes it's unrealistic. But at the same time, this is what our challenge of our customers have, so that's the challenge that we face. So one of the things we wanted to do is we wanted to build a method development plate, and we did. So we actually have 5 polymeric sorbents. So these are polystyrene divinyl benzene based, they're polymer based. And then they come with different modifications to them. Strata-X is simply a hydrophilic modification. Think of this as straight reverse phase. XC is a cation exchanger. XCW is a weak cation exchanger. XA, anion exchanger. XAW, anion exchanger. Most of the things that we're dealing with, luckily for us, are basic molecules. And so we had to make a decision to omit one. We couldn't fit on the plate. So in full disclosure, we omitted the strong anion exchanger. We find that we're not dealing with that many weak acids these days. So 3 columns, 4 wells of each. I'll show you a picture of this. But the real big benefit of the polymeric sorbents is 2 things, in my opinion. Number 1, huge capacity. Number 2, they use, you can dry them down after you wash. So when every time you're automating, if anybody's here done solid phase extraction, sometimes you have to sit there and watch it. You're just watching drips. It's literally watching paint dry. The polymerics, when you automate them, you simply pull a bunch of air through it in between the wash and elution step. So in terms of walking away, it becomes very, very convenient. We wanted to pull some markers, and so we just kind of went into our cabinet and admittedly pulled out a few molecules that we knew differed from a chemical property standpoint. Amitriptyline, tricyclic antidepressant, pretty basic, decent log P, 5.1. We know how to handle it chromatographically. Metoprolol, which I believe is a beta blocker, very low log P, 1.8. pKa, pretty similar though, pretty polar guy. Prednisone, obviously working with steroids. Everybody wants to understand the challenges of those. But again, a lower log P, but the pK very high. And then diclofenac, which off the top of my head, I believe is a non-steroid anti-inflammatory, but halogenated and acidic. So we wanted a mixture of acid bases and neutrals. We wanted a mixture of high log Ps and low log Ps, simply to kind of pick some markers to show you guys. So we then, working with our Tecan friends, we decide that here's the buffer solutions that we want to exchange. We want to take a look at acidic buffers, neutral buffers, formic acid, elution of high pH, and kind of move forward. One thing I do want to point out here though is that our wash in this procedure, if you can look there, the wash 2, 70% methanol. We're very aggressive here. And this is maybe more aggressive than some people will be. And the reason we're doing this is built mostly around small molecules that we know. And not only that, we are actually encouraging the use of ion exchange mechanisms. Ion exchange mechanisms, when you do solid phase extraction, you're essentially doing chromatography on 3 or 4 theoretical plates. So you have to do it very quickly. You don't have a long column to actually be able to partition very much. Ion exchange mechanisms are thermodynamically about 10 to the 7th stronger than reverse phase. So if I can stick my analyte ionically onto a media, I can then be very aggressive with the wash. And that is a huge benefit in terms of cleanliness. And so in terms of a little bit of experimental bias, it's built after small molecules, and it's definitely encouraging the use of ion exchange mechanisms. I think that's simply our philosophy in terms of sample preparation when we approach SPE. So again, not to get into the development of the chromatography, but we had one method that we could run on our mass specs. It's pretty simple at Kinetics. These are these core shell materials, very fast, about 5 minutes, formic acid and water, nothing very special, there's no smoke and mirrors going on. It's a busy slide, but this is what our plate looks like. And just to show you, so you see the columns are the 3 columns of different media. So the 3 columns of Strata-X, polymerically bound, simply reverse phase, then our cation exchanger, 3 of that, then our weak cation exchanger, then our weak anion exchanger. Now a couple explanations. In terms of in each cell, you'll see the phase on the top, X, then sample, and then NN. So this is, the first letter is the wash, the second letter is the elution. Neutral loss, neutral wash, neutral elution. Next one, acidic load, apologize, it is load and then elution. Basic, load, acidic, elution. And we simply built a matrice. We built different conditions across different medias, and we're able to systematically go through a variety of different conditions and then take a look at the performance. As you go down, you'll see a lot of samples. E-reference is a post-extraction spike. So we use that as in terms of giving our recoveries. We measure absolute recovery through post-extraction spikes in our laboratory. So it's a performance metrics that we use quite commonly for extraction procedures. And then obviously having a few blanks throughout there simply to take a look at and see what a blank actually looks like in terms of your cleanliness. But again, it looks like a busy slide, but if you really focus on it, nothing's very challenging about this. We simply built a matrix to systematically try as many conditions as we possibly could across 4 different solid phase extraction medias. And luckily, to do this by hand, as you can imagine, would be awful. And we've done it, and it is awful. And so with the help of Tecan, we were able to automate it. Programming this into our EVOware system did not take very long. All of the polymeric sorbents themselves perform very, very similarly across the plate. And simply, again, using the EVOware system. We even recently, we've taken this a step further, and we'll talk about that, but we recently put this on touch tools for a customer and just demoed it out. And so writing the script was very, very easy for us. Matter of fact, I would argue that we spent more time optimizing the vacuum parameters than we did writing the script, which was pretty important. But some of the results, and I know this is small, but I wanted to go fast for you guys. As you can see, different molecules prefer different conditions. Not surprising. So for the acidic molecules, they tend to perform on a little bit better on anion exchangers under basic load and acidic wash conditions. We did see a couple big surprises here, though, and I believe it is diclonophac, its highest performance being on Strata-X, true reverse phase, under acidic load and the basic elution conditions. So when you run these, you get surprising results. So and we're very good around sitting around a table and being impressive and trying to impress each other with our chemistry knowledge. Oh, it's a cation exchanger. It's going to work like this in my experience. But there's a lot of value in the empirical data. And you'll be surprised a lot of times on the cleanliness and the recoveries that you receive in conditions that necessarily surprise you. Again, as I mentioned, solid phase extraction, you're not dealing with a lot of theoretical plates. And sometimes cleanliness will overcome recovery. So by not retaining maybe everything and by washing heavily, you'll actually get better recovery than say you were in using something that theoretically would hold on to the molecule a lot stronger. So all of this data is published in a technical note too, guys, and I don't want to bore you too much with the numbers, but overall, I mean, I think the concept is we want to be clear about is building a systematic approach for method development. So we were able to do this. We've actually rolled this out to a number of customers. There's a customer in the United States called Tandem Laboratories that's actually published on this. We've ran this procedure a number of times now on numbers of different molecules, and all I can say is that it works very, very well. The total script time for us is about 47 minutes. And so we simply load a spike in analyte. In this particular case, those were at 25 nanograms per mil, but we'll find something that's clinically relevant. We'll spike it in matrices, leave it on the deck, press go, and walk away. And then we'll have a collection plate waiting for us at the end of the day. We'll throw that on the mass spec, and then we'll have pretty good results in terms of what media we're going to do. I will say that the next phase of this is going to be optimization. So we find a media and some conditions that work pretty good. We actually take that, and we're going to actually build onto the Tecan and optimization step. So it looks good on Strata-XC. Let's take a look at another plate. Let's really tweak. Let's hone in on different conditions. Is there a difference between pH 8.8? Is there a difference between 9.0? Matrix effects, things of that nature. So that's the next step. The Freedom EVO 100 has made things incredibly easier in terms of pipetting and friendliness. It allowed us to actually take this method development plate and turn it 90 degrees, because before we were doing an 8-channel pipetter, as most of you would do. And so it became more convenient to actually load the plate in a 90-degree format. We have also put almost, at this point, every 96 well plate formatted solid phase extraction and sample preparation product on the EVO at this point. So we've done plenty of protein precipitation. I'll talk about that in a second. Liquid extractions, supported liquid extractions, non-media based protein precipitations. We've really gone through the gambit in terms of what we know about sample preparation, and we've yet to hit a hiccup in terms of automating the method developments. And so that's the last thing I'll bring up. Just some of the example applications that we've been able to publish. Most notably is the validation of an automated method for removing beta-glucuronidase. This is a big challenge in chromatography because people that are using beta-glucuronidase for hydrolysis, they are doing some protein precipitation, but it's usually partial. And